Okay, this is a quick look at my QuadTree. Well, actually, this started as just a custom binary partitioning algorithm because I sort of realised I wasn't going to be able to test against each and every object in the map, and I needed to use some kind of binary partitioning. And so I sort of went along the lines of developing my own custom thing, and wouldn't you know it, it turns out that it works best when used as a QuadTree. So, for example, there's a basic QuadTree version of it. Let's start simply. Actually, if we say 3 objects, that should do. Now, as you can see, I've got a threshold of 2, which means if there's 2 objects in one grid location, I've called them capsules simply because of the way it looked in the code. When I was inserting them into the stack and they sort of bobbed up and down and found their own level, then inserted themselves, I kind of was the way I viewed it in my mind was like a root system for a tree or a plant, where it sort of starts at a root node and sort of branches its way down, and I just sort of envisaged these capsules dropping down the root tree to find their point. So, but anyway, and where there's 2, that's subdivided. And if we add some more objects and do it again, there you go. You see now we've got another 2 in this quadrant, and so it's and this one, and they've subdivided again. Now, originally I was looking at branching slightly quicker, so there's a square root of 3, so you get 9 squares for each, and obviously you can take that to whatever proportions you want. But as I say, it turns out that actually the best way, one of course, would just be one layer on top of another, and thus wouldn't really be helpful. It turns out that a standard QuadTree works the best, and indeed, again, as with QuadTrees, with a lower propagation threshold. For instance, you could wait until you had lots of objects before subdividing, which may initially seem like a good idea, but when you're actually using it and work out how many times it's got to look through all these squares, you realise there's an awful lot of overhead, and actually you're best off making potentially quite deep trees as opposed to shallow trees, which is a little counterintuitive, but it does work a lot better that way. So as you can see, it's going quite deeply now into certain areas. In fact, it goes to 5 layers. But elsewhere, it will have to do very little work at all. And we can ramp this up, and you can see how that's going down as deep as it needs to, 6 layers, 1500, and you can't really see what's going on anymore, but you get the idea. So yeah, that's my very basic QuadTree, and that's the basis for the tech demo for Barbarian Frontier. That's what it uses to send to the client the objects nearby. So, for example, if the client was situated here and you had a radius, it would simply do a check against all the intersecting grid locations, and then check we're inside of those for obviously subgrid locations, and down until it's actually got the actual capsules, the objects inside, and then it can check against those, which means you've only had to check against a small number out of potentially all of the objects in the entire map. That simply speeds it up, and I'll come on to some actual test data of timings of that in a moment. Okay, this is a non-graphical text-based view of representation of the QuadTree we were just looking at. Only this time it's 20 miles, the map's 20 miles by 20 miles, and it's containing 2 million objects instead of just a couple of hundred. It's going down to 10 layers, so that's getting quite deep in places, and what I've actually done is cluster a lot of these objects in the centre, getting sparser to the outside. And if we now run it, there we go, run it a couple of times. So there's some spikes there of 100, it was 125. Most of them are looking like, what's that, 64 milliseconds. to run through, and that's running through, iterating through 1,000 clients, randomly positioned near the centre along with all the objects. So it's iterating through those and checking down through the tree each of the nodes that it gets to, building a list of all the capsules that are in the vicinity of each client. It looks like it's finding an average of 30 such objects contained in capsules adjacent to each client, and then returning that result. So that's iterating for 1,000 clients and returning all of the adjacent objects to those clients in order that they can be now sent down the network to each of the clients to say, well, these are the objects near you that you need to display. And 64 milliseconds isn't a bad time, because I'm looking at about 200 milliseconds for the whole of a tick, which will be processing the client input, moving them about, and doing collision detection, etc. And then this will be the returning the results back to the client of this is what you need to display. Some of which, for instance, trees and things, buildings, can be cached client-side, or the server will have a small cache knowing what it sent, so it doesn't need to send this all the time, only the stuff that updated, obviously. Okay.